Welcome to chemistry lesson 5.06 on ionic bonding. And in this lesson, we're going to kind of bring all the things that we know about ions together and talk about how they combine to form a compound. Well, we need to start back up in lesson 501. We looked at the orbital diagram notation for sodium. And we said that let's just write it in electron configuration. So let's talk about the sodium ion. And we said, let me put sodium underneath it. Nah, you know what? You could almost flip back. So the sodium ion is 1s2, 2s2, 2p6. Sodium is 1s2, 2s2, 2p6, 3s1. But the sodium ion gets rid of that 3s1 electron, and that leaves us with an octet in my valence. So my valence electrons are here. Notice too that this has the same electron configuration as neon. So we've achieved Nobel gas stability. So this is after we've lost the 3s1 electron. So this leaves us sodium. The atomic number for sodium is 11. I have 11 protons, but now I have 6, 7, 8, 9, 10 electrons. So the sodium ion overall has a +1 charge. And I know we looked at fluorine, but we said all of the halogens are the same. So let's look at chlorine. So the chloride ion is going to be, if we do it in Nobel gas notation, neon, and then it's going to be 3s2, 3p6. Usually chlorine is 3s2, 3p5. But for when it becomes an ion, it gains this electron. So in this case, chlorine has 17 protons, but we're going to have a total of 18 electrons. And so chloride has a -1 charge. And in this case, we lost an electron. So this guy lost an electron. And this guy gained an electron. Now remember, we said in our bonding overview, you don't have to always gain or lose, you could share, but that's a different type of bonding. So in this case, they got to their Nobel gas, and by the way, this is the same configuration as argon. So the chloride ion has, this is equal to argon. So both of these have got to their octet, and they've gotten to a Nobel gas configuration, which makes them very stable and very happy. But what ends up happening is we have these opposite charges. Guys, what do opposites do? Opposites do. If you have opposite charges, did you say attract? Opposites attract. Anytime you have positive charges and negative charges hanging around, they're going to attract each other. And that's what happens here. It's the attraction between the opposite charges. So this results in an ionic bond. Sometimes people mistakenly say that gaining or losing the electron causes the bond. No, it causes the ion. So remember, we call these ions, atoms with a charge. And back a couple of chapters ago, we talked about how you find that charge. So if you have one more proton or one less electron, you're going to have a +1 charge. You have one more electron, you're going to have a -1 charge. Now, they don't just snap together, and I'm going to do, I should have probably color coded these off to bat. We're going to keep chloride as green. And I'm going to make sodium blue. And the sodium ion, the radii change a little bit when they become ions. I'm just going to put a plus sign there. So these guys attract. They kind of snap together. But we don't get lots of little, so if we start with one, I'm going to start mine down here. So from now on, I'm not going to label, I'm just going to draw a chlorine and a sodium. And what we said before is I don't get a bunch of these floating around in space or in my solid. When they start to form, they form in a repeating pattern. So I have a chloride, I have a sodium. There's still a little bit of a tendency for charge here. So what'll happen is, remember this is negative and this is positive. This is going to begin to build, and we'll get sodium here, and we'll get chloride here, and sodium, and chloride. All right, let me see if I can go a little faster. And they have a repeating pattern in every ionic compound. It's a little bit different. So I'm going to go ahead and draw this, and then we could also watch it build as we go back. So we would have sodium here, sodium here, sodium, sodium, and this would be a chloride, 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 chloride. And this is unique for every ionic compound. They go together just a little bit differently. Remember, we said in the last video that we call this a crystal lattice. The smallest unit of a crystal lattice, or the single repeating pattern, so this is kind of like my base unit. This is called a formula unit. In reality, we don't treat molecular formulas, and so the formula unit for this would be NaCl. We don't treat these any different between ionic and covalent once we get rolling, but you need to understand that at its foundation, understanding that ionic compounds go together in a crystal lattice rather than individual little molecules. If this was covalent, this NaCl would live over here, and this NaCl would live up here, and this NaCl would live up here, and this NaCl would live down here. But in an ion, it's different. And the reason I think it's good to know this, there are entire branches of science that study crystal lattice structures. It's called crystallography. If you've ever watched the show Breaking Bad, Walter White has his PhD in crystallography. That's all he does, is he studies the crystal structures. That's why he's so good at making crystal meth. Crystal meth would be an ionic compound. It has a crystal structure. And the only reason I know that is because I watch Breaking Bad. Okay, so what are our takeaways here? An ionic bond, and let's write out a definition for that, shall we? Let's put definitions in here. Ionic bond is a bond that forms between two oppositely charged ions. Oops, and I just realized I missed a couple other pieces of information. So let's get a few more definitions down here. My chloride has a negative charge. Negatively, why do I not want to be there? Negatively charged ions are called anions. Positively charged ions are called cations. And if you want a tip to remember that, you can write out positive as positive because cations have pause. Get it? So the better definition is a bond that forms between two oppositely charged ions. We could also say a bond that forms, or we could say, or the bond that forms between cations and anions. All right, so our takeaways here are that, and these are main groups, so we're talking about usually, well, that's not true. We have intertransition metals for ions as well. So we have, and shoot, I keep thinking of things I forgot. The cations are the metal, and the anions are the nonmetals. Okay, that's everything. So what are our takeaways? To achieve Nobel gas configuration, especially main group elements want to form ions. Those are atoms with a charge, and they have positive or negative values. Positive ones are going to be cations, those are the metals. The negative ones are the anions, those are the nonmetals. The bond actually forms when those opposite charges attract each other. And they assemble themselves automatically due to charge and shape into something called a crystal lattice. And this crystal lattice is unique for every ionic compound. It's also what gives rise to the properties we talked to in the last video, like brittleness and high melting point. All right, so that's everything you need to know for this chapter about ionic bonding. Thanks for watching and have a good day.